Well, good morning and welcome to Nani Notes. Today's topic is completing the square for parabolas. Now, if you have the McDougal Littel textbook up there in that upper right-hand corner, you would find this on, I'd say section 10, or chapter 10, section 5, so 10.5. Look for it there. And we're going to travel from the known to the unknown here. I'm going to take a parabola and we'll graph one in its standard form. Then we'll go over what a perfect square trinomial is, and then we're going to go and convert between the standard form, vertex form. Now, up above there, you can see we've got this the standard form where A, B, and C, in this example, x squared minus 12x plus 22. For the purpose of this video, we're going to always have the a, the coefficient of the x squared term 1. Well, this will be the introductory, and a doesn't have to be 1, but we're going to start with that. Let's walk before we run, and we're going to convert that. We're going to convert that into this form: y equals the quantity x minus h squared plus k, where h and k is the vertex of the parabola. So that is the process that, again, we call completing the square. And we'll do maybe up to 7 examples. We'll see how, if this video is dragging, maybe we'll cut it short. But again, we're going to start. We're going to look at graphing. Then we're going to review what a perfect square trinomial is. And then we'll graph maybe 2 in the vertex form. But then we can see we can do it without graphing. So are you ready? Let's hit it. Okay, here we go. Review time. Now, you probably, in this example, the coefficient a is 1, b is -6, and c is h. And again, for our examples, we are going to stick to a equals 1 in this video. Now, we did this before. We said, okay, we're going to solve for the axis of symmetry. And I'll go a little faster here because we've already seen this on the previous video. And we substitute, and we come up with an axis, a vertical line, x equals 3. That is the axis of symmetry. And then, I guess we got to clear that out of the way. I could take, that's ugly, let's get this out of here. I could substitute values, and let's say I came over here and said, let's find the values for y. And we'll take these given values of x, and we did this before. We said, okay, well, evaluated at x equals 3, and we can plot this point. We've got 3, -1, so that's going to be our vertex. Very nice, easy. Now we're going to substitute. Let's go for 2, and we've got, again, y equals, in this case, y equals 0. So we've got the point 2, 0. And then we're going to say, okay, let's go this way. 1, 3, 0, 8, and -1, 15. And of course, that was our parabola. That's what we did before. And that's cool. We can do it that way. But we're going to do something a little bit different. So now, let's just take a gander over here. Let's just remind ourselves what a perfect square trinomial is. Trinomial means we've got an expression with 3 terms. This looks like 2 terms. Well, but when we multiply them together, we are going to get 3. And we'll just explore these 2 just to refresh your memory. Now, I could represent this as the quantity x plus 7 times the quantity x plus 7. And then we could do that thing you learned way back when, the whole FOIL thing. First, outer, inner, last. The first terms, x squared. Now the outer terms, in this case, x and 7, well, it's going to be 7x and 7x. The last term, 7 squared, and that's going to give us 49. Oh, ruh-roh, I didn't show up over here. So again, you'll have -5x plus 25. So the forms for the perfect square trinomial, which you probably saw in a previous lesson, look like that. Okay, that's just a reminder. Now let's see about converting. We're going to convert this one and we're going to graph it. So we're going to change this standard form into a vertex form. Now, again, this is going to work when we're doing the a is equal to 1, the coefficient of x squared is 1. Look at that negative 6x, that's your b term. Negative 6 is the coefficient. What's half of negative 6? That would be negative 3. Now, if I were to square this thing, I know what I'm going to get. I'm going to get x squared minus 3x twice, which is minus 6x, plus 9, right? But that's not what the equation said. The equation said plus 8. So how are we going to do that? Well, we're just going to adjust. We'll subtract 1. And therefore, my equation is going to look like this. I subtract 1 here. You see x squared minus 6x plus 9 minus 1 is x squared minus 6x plus 8. Well, I took away 1 there. I'm just reflecting that up here. So I've changed this equation into this equation. Now, the whole reason we did that, if I look at this form, hk, it's x minus what? X minus 3. H is 3. And plus, or I'm saying plus what? Plus a negative 1. Notice, this is a negative 1. This is a positive 1 because the form says x minus h plus k. Okay, well, we're going to graph this one just because it's kind of cool. And let's start with this. We've already done this conversion. We've already converted this. This is the beauty of the HK form. I'm just going to put in, oh, where did it go? I'm going to put in the vertex. I'm going to plot 3, negative 1. That's the vertex that we solved for. Well, I know that the axis is here, and I know what this parabola is going to look like. Now, I'm going to take this parabola. This is y equals x squared. Again, the coefficient is 1. I'm just going to shift it over there. See that? This is y equals x squared. And this is that same parabola moved to the vertex 3, negative 1. Pretty cool, huh? Okay, let's try another. Let's do something else here. Oh boy, this is going to be so easy. After a while, you're going to say, I can't believe we thought this was hard. Look at this. Again, x squared minus 6x. Focus on the b. And I verify the coefficient of x squared is 1. Minus 6x, well, half of 6 is 3. So when I expand that, again, just like before, when I square this term, x minus 3 times x minus 3, you can do the FOIL if you need to, but you'll get that pattern memorized. First term squared, twice the product of the two terms, and the square of the last term. Now, how do we adjust it? We are going to have to, we're going to have to show an adjustment there. I'm going to have to add 5. Well, if I add 5 like that, because now my equation represents x squared minus 6x plus 14. 9 plus 5 is 14. And now I can rewrite the equation. It's right there. What is h and what is k? This says minus 3 plus 5. hk, both positive. And if we were to graph this one, and well, are we going to? Okay, well, doggone it. Okay, we'll graph this one really quick. 3, 5 is the vertex. It's right there. It's going to open upwards. I know it's got an axis of symmetry that looks like this. And I could work out all these points. Think about it this way. Instead of actually substituting and going and solving for all these, just say, wait a minute, I'm moving 1 to the right. Y is going to be 5 plus 1. When I move 2 to the right, I'm going to add 2 squared. I move 3 to the right. Sorry, the left. Sorry, 3. I'm going to move 3 units from the axis of symmetry. 3 squared is 9. 5 plus 9. 4 units. 5 plus 16. So in the end, it looks like this. And my parabola, again, this is y equals x squared. I'm just shifting it like that. Pretty neat. All right. Well, the rest of these, maybe we'll hold off on the graphing because we got enough to do here. All right. What's half of 14? Well, that would be 7. What's 7 squared? That would be 49. Pretty easy. What's my adjustment? Well, I got 49. I wanted 40. I'm going to have to subtract 9. So that's your equation right there. I'm going to write that. X plus 7, quantity squared, minus 9. Now, this is going to be interesting because now I want you to think of plus 7 as x minus a negative 7. The form says x minus h. So h is going to be negative 7. And the k is going to be negative 9. This one is going to have its vertex in the 3rd quadrant. Okay, and I think we did a graph. Okay, well, we'll see what the graph of this looks like. Can we? The vertex is down there. The axis is there. I can move 1 to the right, up 1, 2 to the right, up 4, 3 to the right, up 9. Do you see what I'm doing there? And I know those points are on the other side. And that's where my parabola is. So I've just taken this parabola and I've shifted it down there like that. Beautiful. Again, if you needed to do it that way. But you can just see, move 1 unit, up 1, move 2 units, up 4, because this has a coefficient, or the a coefficient is 1. It's y equals x squared shifted. All right, no more graphing, I promise. Let's just get a couple of these under our belt. What's half of 18? That would be 9. What's 9 squared? Well, that would be 81. 81 is not 86. I'm going to have to adjust. I'm going to add 5. So that's your equation right there. Are you kidding me? It's that easy. Now, I could then say, what is the h and the k? I've got x plus 9 or x minus a negative 9. No, I don't have it keyed in here, so hang on. So that'll be negative 9, and the k is plus 5. Pretty sweet, huh? All right, just a couple more and we'll be done. In this equation, x squared, the b term is negative 6, and we'll take half of that. And that will be 3. When we expand this, we're going to square the x minus 3. We generate a plus 9, which has an adjustment, requires an adjustment of 7. 9 minus 7 is 2. So my equation is right there. h and k, x minus h is 3, and the k, oh wait a minute, it's bogus right here. Who's the editor here? Should be minus 7. And the k is minus 7. Nice. All right, just a couple more. They're going fast now, and then we'll call it. Yeah, I'm giving you all easy ones where b is a even number. Otherwise, we get fractions, and we'll have examples like that. Maybe not in this video. Half of 2 is 1. So I'm going to write it this way, x minus 1. When I square that, can I expand that? Sure, I can. Negative 1 times negative 1 is positive 1. I have an adjustment of 4. So my rewritten equation, x minus 1 quantity squared plus 4. H is 1. K is 4. Nicely done. All right, just a couple more. Promise. How about this one? You're getting the pattern, right? And again, we're checking, always verify that the coefficient of x squared is 1. I'm going to take half of the b term. That's going to be 10. I expand that. 10 squared is 100. What do I do to adjust? 100 minus 12 is 88. So there's my equation. Wow. It's that simple. X minus h is negative 10. And then k plus a negative 12. Again, in the third quadrant, negative 10, negative 12. One more, and we'll be done. Oh, dang, they're all even. Okay, well, we'll call this the easy video. We're going to take half of b here. Half of 16 is 8. When I expand that, I've got a constant term of plus 64. My adjustment, minus 11. Minus 11. Nice. So I can see my equation looks like this. X minus h quantity squared plus k. X minus a positive 8, that quantity squared, plus a negative 11. And with that, we're going to call it good. So practice from your textbook, and in a future video, we'll talk about when it gets a little tougher. So I hope this has been helpful, and thank you for watching 99.